From falling apples to orbiting planets, this is how we learn to understand motion. Watching the sky fall 3000 BCE in Egypt and Mesopotamia. Before we understood how things fall, we watched how they moved. The Babylonians charted planets. Egyptians built pyramids using intuitive mechanics, levers, pulleys, and ramps. Motion meant survival. The Greek debate begins, 400 BCE Greece. Aristotle believed heavier things fall faster. He thought objects naturally seek rest and the heavens followed different rules. But another Greek, Archimedes, saw things differently. He studied levers, buoyancy, and proved that math could explain force. India's seeds of motion, 500 CE. Indian astronomer Aryabhata described Earth's rotation centuries before Galileo. He questioned fixed space and described relative motion, a deep insight long before its time. Motion in the Islamic Golden Age, 900 to 1200 CE, Arabia, Persia. Muslim scholars challenged Aristotle. Ibn Sina, Avicenna, spoke of inertia. A body stays in motion unless stopped, an idea that Newton would later make famous. El-Biruni calculated gravity by studying falling bodies and mountain heights. Galileo's rebellion, 1600s Italy. Galileo dropped spheres from the Leaning Tower of Pisa and proved Aristotle wrong. Objects fall at the same rate regardless of weight. He built inclined planes to measure acceleration and invented the idea of experimental physics. The Apple and the Law, 1687 England. Isaac Newton sat beneath a tree. An apple fell, and a question rose. Why does the moon stay up but the apple fall? His answer? Gravity. With 3 laws of motion and a law of universal gravitation, he united the heavens and earth in one theory. Energy enters the picture, 1700s to 1800s. Mechanics grew beyond force and motion. Scientists like Émile de Châtelet connected Newton's ideas to energy. Work, power, and kinetic energy all became tools to explain engines, steam, and factories. Einstein breaks the clock, 1905 Germany. Newton's laws ruled until Einstein looked at light. He found that time and space aren't absolute. With special and general relativity, he redefined motion, gravity, and reality. Quantum twists, 1900s global. At atomic scales, mechanics became strange. Electrons don't orbit like planets, they blur like clouds. Quantum mechanics showed that motion is probability. Today's mechanics, from atoms to galaxies, mechanics now powers bridges, rockets, roller coasters, and brain implants. We simulate black holes, build exoskeletons, and land robots on Mars. The same laws that explain a Ball's arc guide GPS satellites through curved spacetime. What is mechanics? Mechanics is the science of motion, the poetry of forces. It began with falling rocks and now explains why galaxies spin. It's not just physics, it's the geometry of reality.